Mr. Potter. In today's video, we're going to talk about dealing with dynamic data structures. The idea is that when we're writing a program, we may not know how many pieces of data our program is going to need. And so we need the ability to kind of develop data on the fly, to kind of create variables on the spot. And one of the easiest ways to do that is through arrays. So the thing is, I may not need one int, I may need 10 ints, or 15 ints, or 20 ints. And I need some way to be able to kind of change that on the fly. So I'm going to go ahead and create an array of ints. And notice how I'm using this open and close bracket to denote this array. So I'm going to have int array, and we'll go ahead and call this nums. And I'm going to say this is going to be a new int array, and inside the brackets I'm going to put 10. And what I'm basically saying is create an array with 10 spots. And what I can do with those 10 spots is I can actually go through this list. Now, what's important to remember is that our first spot is spot 0, and our last spot is spot 9. So if I want to go through here and say for int I gets 0, I less than 9, 9, I plus plus, then I can say nums sub I is going to get I times I. And so what this should do is this should fill up my array with all of the squares from 0 to 9. And so what I can do later is I can set up another loop for int I gets 0, I less than 9, I plus plus, and do system.out.print, and I can print nums sub I, whatever's in box I, plus a space, just to space everything out, and then system.out.print line, just to make things look nice. If I go ahead and run this, then I'm going to see the squares. Notice that I said less than 9, and I could actually make this less than or equal to 9, and run it again, and I'll actually get all the squares up through and including 9, so I get that 81. The thing is because I have 10 spots are numbered from 0 to 9. One of the things that I can do is, rather than me personally as a programmer having to keep track of the length, I can ask Java to keep track of the length for me. I can say, just make sure we're less than nums dot length. And what's important to notice here is that length for arrays is a public instance variable, not a method. So in other words, it's not nums.length with parentheses like it is with strings, but it's just nums.length. So I've got this, basically creating an array of nums where I've got the perfect squares. Now I can do something very similar to this, making an array of doubles. So I'll say double array vowels gets new double, and we'll go ahead and make this 10. And what I'm going to do now is I'm going to fill up this list. So for int I gets 0, I less than vowels dot length I plus plus, and I'm going to say vowels sub I is going to get math dot square root of I, something that I know will give me double values, and then I can print this list just like I did above. So for int I gets 0, I less than vowels dot length I plus plus, and system dot out dot print line, or just print val sub I. And with a system dot out dot print line at the end, just to kind of make everything print nicely. And so what I'm going to do is my first row of data will have the perfect squares up through 81, and this one I probably should have put some spaces in there to make this a little bit more legible. But if I do that to kind of force it to be a little bit more legible, I'm going to see 0, and the square root of 1 is 1, and the square root of 2 is 1.414 approximately. Square root of 3 is 1.732. Square root of 4 is nice. And this keeps working up until I hit the square root of 9, which is 3. So this is one way that I can assign it. I can go through a loop and use a loop to kind of assign these values. Another thing that I can do is I can explicitly state the value. So I can do something like char lets equals new char sub 4, and I can say let sub 0 is equal to h, and I can say let sub 1 equal to an I, and let's sub 2 to be a J, and let's sub 3 to be a K. You can certainly assign these however you want. You can assign them by explicitly stating index by index, or setting up some type of loop to do this. There's something else that we can do, something called an array literal. So I can say int array digits being equal to, and what I'll do is, rather than say a new int, I'll just go ahead and start using a braces for a list. So I can say my digits is going to be 3, followed by a 1, then a 4, then a 1, then a 5, then a 9, then a 2, then a 6, 5, 3, 5, 8, 9, 7, 9, and closing the brace. So what I've got here is I've got a kind of like we have string literals, which is a string within quotes, rather than using the new constructor. I can do an array literal in that same way, creating an array by creating a list of that particular type enclosed within braces. And just as before, I can do a for loop, int I gets 0, I less than digits, dot length I plus plus, and this time I'm going to go ahead and do digits of I with no space. And I can go ahead and get that to run. And of course, if I were to do this correctly, where's my error? Stop, stop, stop. Let's go ahead and get this to run. What did I do wrong? Build error, line 30. Huh. I think I might have an extra brace here. The thing is, whenever you open the brace, it automatically puts the closing brace on another line. That is one thing you have to watch out here. Okay, so let's see, there's my open and close there. It's having problems with lets. Should be a char array. Silly me. So there I've got my digits of pi written out. One other thing that I can do is I could go ahead and declare an array, string array words gets new string array with 5, and I can go ahead and use a loop to prompt. So I can do for int I gets 0 I less than words I plus plus, and I can do the prompting like we've done before. So I'll go ahead and on the line above I'll do scanner in gets new scanner system.in, and of course because I'm doing a scanner I definitely want to import that statement, so we'll go ahead and import java.util.scanner, and then I want to go down here, and inside this loop I want to set up a loop that's going to prompt. So I'm going to go ahead and say words sub I are going to get in dot next, and of course it would be helpful if I did system.out.print enter another, enter a word, or enter word plus I. Just a prompt for word 0, word 1, word 2, word 3, and so forth. And then I can do another loop afterwards, and I gets 0 I less than words dot length. I do need to remember that it's words dot length semicolon I plus plus, and then I can just go ahead and system.out.print words sub I plus a space. And then finish that off with the system.out.print line. So I can do a loop to kind of prompt for a certain number of words. So it says enter word 0. I'll say welcome. Enter word 1, 2. Word 2 AP, word 3 computer, and word 4 science, and it'll say welcome to AP computer science. Now in this case I had the length fixed at 5, but it certainly would not be difficult for me to prompt the user for the number of data items, in which case I truly can make this dynamic. I could have had them prompt for some number and then used integer.parseInt to set up a statement that would declare an array of strings. So that definitely is an option here, and this makes it so that our programs are a lot more dynamic. I don't have to do an explicit system out print line for each data value. I can put it inside a loop and just go through what's in box 0, what's in box 1, what's in box 2, what's in box 3, all the way down to the length. And there's one other array that I want to talk about. So let me go ahead and terminate this program real quick. What I can do is for this last piece of data here, since it is a string, I can create a char array. We'll call this letters gets, and I can ask what words sub 4 dot to char array. And what this will do is this will actually create an array of chars so that I can treat this list as if it were an array. Because when we think about it, these strings that we have are really a concatenation of individual chars made into some string. So I can do for int I gets letters dot length minus 1, letters greater than 0, or I greater than 0. I 0, I minus minus, and I can kind of go backwards through this. I can system dot out dot print letters sub I, and finish this up with the system dot out dot print line. And so if I run this again with the same input I had before, where it's going to say welcome to AP Computer and Science, it's going to print welcome to AP Computer Science, but notice that it also prints the word science backwards, or at least it would have printed out completely had I included character 0. But I've got this to-char array, which allows me to take a string and actually break it up into individual characters in an array of characters. So I can manipulate that array by traversing through it forwards or backwards. Now, what's really nice about this, and we'll see this in later lessons, is that I can take this data and I can manipulate this data. I can move data from one cell to another cell. And that's going to be our first inkling of how we can actually sort data. Because if we look at data in a telephone book, or if we look at data in most computer systems, it's not haphazardly stored throughout. What actually happens is it's stored in a very clear and concise order, and we can use that order to find data very efficiently. That's where we're headed in this. But I think for here, just knowing how to declare a variable, how to initialize a variable, and how to traverse an array is probably the best stopping point for today. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.